Unit 5, Part 9. In Part 8, I started on the short truth table method, explained the theoretical frame of mind you need to have to understand what you're doing when you're engaging in the short truth table method, right? You're attempting to hone in on a counterexample, right? That is, you're going to attempt to find an assignment of truth values for the sentential variables which makes the premises true and the conclusion false. So you start by assigning true to all the premises, that is, putting a T over or under alongside the major operator for all the premises and a false over the major operator for the conclusion, and then you're going to see if you can consistently assign truth values to the premise to each of the sentential variables to make that so, to make that true, to make the premises true and the conclusion false, right? I say consistently assign, right? Don't make the mistake of thinking that you can make P true in one premise and P false in the conclusion, right? That would be like trying to find, that's Klenk's point on page 87. She warns against this warning, warns against that mistake. That would be like, right, picking a row in a truth table like this, right? Where, right, you're getting it all over the place. Don't do that. It's got to be, right? It's got to be whatever P is, it's got to be the same truth value here and everywhere P appears, right? Okay. So as I said, the most crucial thing to have in mind is if you can find an assignment of truth values consistent with that opening move, premises true, conclusion false. If you can find one, you produce it. It's like having found the row in the truth table, which you would point to and put a star on, right? That's the counterexample. You say, I found it, here it is, therefore the argument is invalid. But of course, if you can't find it, if it is impossible, if it proves impossible to assign truth values to the components consistent with that opening move, where the premise is made true and the conclusion false, if you can't find one, it's because the argument is valid. Okay, so just a very quick demonstration of what that means. This is the argument form for modus ponens, right? The first rule of inference we'll start with in Unit 7 when we start on proofs. The first one on the inside cover of your book, top left, the inside cover of your book. It's a valid argument form, right? It's given any conditional and giving the antecedent of the conditional, you're entitled to infer the consequent of the conditional. If both P and Q and P, you can infer Q, right? Of course, we want it to be valid. It's a valid argument form. See how, if I perform the short truth table method on this, seeking a counterexample, it soon becomes clear that I cannot find a counterexample, that it is not possible to find assignments of truth values to the simple components that make the premises true and the conclusion false. So see what I do, right? I make all the premises true, so I'll make the conditional true, the second premise, which is P, is true, and make Q false, right? The second premise, the conclusion, they're simple atoms, right? They're just single sentential variables, right? I list all my sentential variables as P and Q, right? And what I will find, which will demonstrate to me that this is a valid argument form, is that such an assignment as I have attempted here is not possible, right? I will see that it is not possible to make that true and that false, right? No such consistent assignment will be possible. I'm just stressing this because that's the frame you have to have in mind, right? Don't think, oh no, I can't find one. What have I done wrong? Maybe nothing. Maybe you have a valid argument form. What are you doing here? You're testing the argument form for validity. And if you can't find it, maybe it's because you haven't made a mistake. It's just that there isn't one, which is what you want for a valid argument form. So see how it goes here, right? These assignments, on the second premise conclusion, that's immediately gives me, okay, P has to be true if P is going to be true, right? Q is false. I'm told that Q is false. So I've signed false to the conclusion, which is just Q. And so this, right, this is the terminator thing, right? True, true, false. That's the assignment of truth values that we need for a counterexample. All of them true and the conclusion false. So if the second premise is true, that means P is true. If the conclusion is false, that is false. So P is true and Q is false. Okay, so that means P is true here, and Q is false here. So please pay attention to this bit. Look at that. This is where your mind explodes and goes, ah, okay, it's impossible. Because look, you've got, we began, be clear about this, we tried to assign, right, we were looking for a counterexample because we're testing this argument form for validity. To do, if a counterexample exists, that means the first premise will be true, because a counterexample is all the premises are true, right? So we assign the first premise true, but the assignment to the components of this first premise, as were also necessary for us to find a counterexample, P being true and Q being false, right? On that assignment, we get T hook F, which is F. T hook F is the one case of the hook where the hook is false. So, right, that T there, F there, that makes that false. And that makes that false. And of course, if that's false, it's not true, right? That's a contradiction we've reached. And what is the contradiction telling us? It's telling us that this is in fact a valid argument form. It's telling us that it's not possible to construct a counterexample to this form, which is as it should be because it's modus ponens. It's the valid argument form. Okay. All right. I'll just start actually doing 3D in the next part.